So our first question on 7.2 says, explain the difference between the z-test for the mean. Remember that mu is mean of population using rejection region or rejection regions, and the z-test for the mean using p-value. So it says, do you see any difference using a p-value deciding about null hypothesis, alternative hypothesis, or using rejection regions? So let me go to the board and explain this quickly for you. So what we learned so far? We learned that when it comes to hypothesis testing for the mean, you have, in this case, that sigma is given. This is the flow chart that I sent it to you yesterday. And here we have two different strategies. The first strategy is to use a p-value, or you can use a rejection region. First, you check to see if n is greater than or equals to 30, or population is normal. Then we identify our, is it our alpha or is it something else? What is the second step? The second step is null hypothesis, alternative hypothesis. Very well. H naught mu is greater than or equals to k. HA says mu is less than k. Or you have this case that says H naught mu is less than or equals to k. HA mu is greater than k. Or you have the following case that you have a two-tailed test says H naught mu is equal to k, and its opposite or complement mu is not equals to k. Then we move on to find alpha. After we find alpha, we find our standardized statistic, which is x bar minus mu divided by sigma times square root of n. And after that, we find the area. We find the area, and after that, we find the p-value. Remember that assuming different cases, p-value is different. If this is the first case, p-value is equal to the area to the left. If it's a right-tailed graph, p-value is equal to area to the right. Area to the right. And if you have a two-tailed graph, p-value is equal to 2 times the area. And finally, we make decisions. 7, if p-value is less than equals to alpha, we reject the null hypothesis. Reject the null hypothesis. And if p is greater than alpha, we fail to reject the null hypothesis. Okay. So what are we actually doing here? We are looking at p-value and alpha. Remember that p-value is probability, alpha is also probability. Area below the graph of the curve. So what are we actually doing? We're trying to compare the areas. Compare the areas. So this was your, for example, your alpha. Then this is the area. And then p-value. P-value is either smaller than alpha or it's larger than alpha. But whatever it is an area. So we're trying to compare the areas. The second technique is using rejection region. How rejection region works? First, we check to see if n is greater than or equals to 30 or population is normal. Then we identify the type of hypothesis that we have. The same, step 2 are the same. And then in the third step, we identify our alpha. And then we use our, for example, you can use inverse norm to find your, what do we find now? By using alpha, we're actually finding our critical value. Critical value. Z sub 0, or if you have two-tailed, is negative Z sub 0, positive Z sub 0. So remember that if you have a left-tailed, it is just inverse norm of your alpha. If it's right-tailed, then it is inverse norm of 1 minus alpha. And if it's two-tailed, you just need to find one of them, use positive negative sign. Two-tailed, we get inverse norm of alpha divided by 2. It gives you the critical value. Okay, then you move on to the next step. You find your z, which is the same as before, x bar minus mean divided by sigma times square root of n. Then now you're comparing z with z sub 0, comparing values on the horizontal axis. So step 5, if z is in the green area, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. We fail to reject the null hypothesis. So what are we doing now? Now you are taking two numbers on the horizontal axis. So alpha and z sub 0, they are equivalent to each other. When you find alpha, it means that you're finding z sub 0. And then when you're finding z, it's equivalent to your p-value. This is your z. So these are, both of them are equivalent to each other. It doesn't matter if you use p-value or use rejection region. You get the exact same final result. Okay, so by going over that review, what would be the answer here? In the z-test using rejection region, the test statistic is compared with the level of significance alpha. The z-test using a p-value compares the p-value with the critical value. No, of course not. P-value is compared with alpha because these two are areas. Area with area. And if we were using rejection region, z-values with z-values. In the z-test using rejection region, the test statistic, z, is compared with critical value. Yes, of course. So far, so good. The test statistic Z is compared with critical value. The Z test using a p-value and compares it with the level of significance. Excellent. This is the correct answer. Area with area, area with area, p-value and alpha, both of them are areas, area with area, and Z with Z. So this is our correct answer. So question 2 says, determine whether to reject or fail to reject the null hypothesis at the level of significance alpha 3%. This is part A. B, alpha is 2%. So let us first focus on alpha 3%. So take a look at this. Your null hypothesis says mean is 149. Your alternative hypothesis says mean is not 149. And P is given to us. So we have these information. These are given to us. Our P is 2%. P is less than or equals to alpha, which is 3%. What's the meaning of that? It means that we reject the null hypothesis. So just take a look at this. Reject null hypothesis because P is greater than? No, of course. P is less than. So fail to reject, no, we know that we have to reject the null hypothesis. So this one is not correct as well. Reject the null hypothesis because P is less than 3%. Yes, this is the correct answer for us. And B says, hey, now you have alpha 2%. This is your new alpha. Our P is 0.02, a little bit larger than 2%. P is larger than alpha 2% because of 0.7. It means that we fail to reject the null hypothesis. So we'll take a look at this. Reject? No, we don't reject. We fail to reject. Fail to reject. Why? Because P is greater than alpha. Fail to reject null hypothesis because P is greater than alpha. This is the correct answer. So what do we have here? You have a p-value for hypothesis testing. Decide whether to reject or fail to reject the null hypothesis. Now we are having different alpha values. What was alpha? Level of significance. So P is 0.1027. So it's more than 10%. It's more than 10%. So let us take a look at the first one. The first one says, hey, alpha is 1%. So of course, P is greater than alpha. In this case, your P-value, which is 0.1027, is greater than your alpha, which is 1%. So that's obvious. P is greater than alpha. It means that we fail to reject the null hypothesis. So let us look for the correct answer. Reject? No. Fail to reject. Very good. Fail to reject because p-value is greater than alpha. Of course, this is the correct answer. Let us move on to part B. So now your alpha is 5%. Again, your alpha is 5%. it's smaller than p-value, which is more than 10%. So it means that we fail to reject the null hypothesis. Well, so reject, no. Fail to reject, yes, because p-value is less than. No, p-value is larger than. So the correct answer, fail to reject the null hypothesis because p-value is greater than. There we go, p-value is greater than. And finally, if your alpha is exactly 10%, again, remember that our p-value is more than 10%. Your p-value 0.1027 is more than just 10%. So it means that again, we fail to reject the null hypothesis. So reject, no, fail to reject, okay, we can move on. Fail to reject null hypothesis because the p-value is greater than alpha. Very well. So let us move on to next question. Question 4. Well, here we have the following. It says, test the claim about the population mean at the given level of significance using the given sample statistics. Claim mu is 30, mean of the population is 30, alpha is 6%, level of significance is 6%, and sigma, population standard deviation, is 3.04. X bar, or sample statistic, is given to us as 29.7. N is also given to us as 53. So note that we don't have to do any calculation. All of these information are given in question 4. Identify the null and alternative hypothesis. Okay, how do we do that? First of all, note that your mean is the complement is not. Since mean is 30, it is our null hypothesis. So alternative hypothesis says mean is not 30. So which one is the correct answer? Mu is 30, mu is not 30. Mu is 30, mu is not 30. Your null hypothesis, your alternative hypothesis. Guys, be careful, it's not D. Why is that? Because our null hypothesis cannot be inequality. It must be equal to, it has to have equal to somewhere. So this is F. Calculate the standardized test statistic. What was standardized test statistic? Z equals to X bar minus mean divided by sigma times square root of N. So what is our X bar? 29.7 minus what is the mean? 30 divided by sigma, which is 3.04 times square root of 53.
Negative 0.72.
Very good. Negative 0.72. This is your Z, standardized test statistic. Negative 0.72. Now question says, find the critical values. Well, let us take a look at the board. Just take a look at the board. Here we go. We have a two-tailed graph. Two-tailed graph, the third category. It says mu is not equal to k, so you get a two-tailed graph. It means that we have to use inverse norm alpha divided by 2. Two-tailed, inverse norm alpha divided by 2. Let's take a look at our calculator. Since it is a two-tailed graph, so we use inverse norm of alpha divided by 2. But what is our alpha? Alpha is 6%. Inverse norm of 6% divided by 2, or 3%. Calculator is just right here. So I turn it on. Second, vars, inverse norm. And here we use 3%. Mean is 0. Standard deviation is always 1 because we're using a z table. So our critical value is negative 1.88. So negative 1.88 on the left-hand side of 0. On the right-hand side of 0, we get 1.88. So the critical value, you have two critical values. Why is that? Because we have a two-tailed graph. When you have a two-tailed graph, remember that the green area, one part of the green area lands on the left-hand side, the other part lands on the right-hand side, two-tailed. So we get two critical values, plus minus 1.88. It's not just one, it is two critical values. Negative 1.88 and positive 1.88. And okay, so take a look at this. You have your z value. You have your rejection regions. Is this number inside the green zone or the rejection zone? Or is it far away? Remember that 0 is here in the middle, and this number, negative 0.72, is in between 0 and negative 1. So this number is actually here. This is your z. It's outside the rejection region. Z is negative 0.72. So the correct answer, reject, no. This number is outside the green zone. We fail to reject. Reject, no. No, of course not. Fail to reject, okay, that's a good one. Fail to reject, why? It says at least 6% significance level, there is not enough evidence to support the claim. Okay, what was the claim? The claim was mu is equal to 30, and this is your claim, okay? Do we reject the null hypothesis or fail to reject the null hypothesis? We reject or fail to reject. Remember that this z is outside the green area. Z is outside the green area. We fail to reject the null hypothesis. Why is that? There is not enough evidence to support the claim, or there is not evidence to reject the claim. Which one? The claim and your null hypothesis are the same thing. So there is not enough evidence to reject the null hypothesis or the claim. It's not about supporting the claim. It's about rejecting the claim. Why is that? Because our claim and null hypothesis are the same. Very well. Use the technology to help to test the claim about population. Your claim says mu is greater than 1,240. This is your claim. Remember that this guy just says that greater than. So this is your alternative hypothesis. By looking at the symbol, you can quickly recognize the type of hypothesis